Our group consists of Bernard, Ellie, and me, Taylor. As a public service announcement, one of our members doesn't have a camera, so we decided to shut them all off. We wanted your main attention on the presentation and not on us. Also, we decided to take screenshots of the code and put them in a PowerPoint slide to talk about them a little easier. We decided to base our project on the popular card game BlackJack. This game is designed to be a two-player card game, the player and the dealer, or the house. The point of BlackJack is to get a card count as close to 21 as possible without going over the value 21. The numbered cards 2 through 10 have their respectable values. Face cards, so Jack, Queen, and King, are worth 10. And when it comes to an ace, each individual player can decide if they want their cards to be 1 or 11. The player is dealt cards and is asked to hit or stand with the value they hold. We decided to do BlackJack because it is a strategy game that depends on the house, or the dealer, to determine the winner or loser. This is a simple to understand game that requires some complex thinking around the situations we used. First, we had to think about the mechanics that made up the game BlackJack. So we had to make different classes for each of the things contributing to the game. So we thought of the design that the user sees, the dealer class, the player class, the deal itself, the cards, and the main as the overarching class. As far as the design of the game, the whole purpose of BlackJack is to play it. So we needed to set up an interface where the user is able to interact with it. We imported tkinter, which is a geometry manager that organizes widgets into blocks. We have an easy-to-read font, Calibri, used throughout the game, with small, medium, and large fonts. I also set the background color to mint green, my favorite color. In the next section, we use tkinter to pack the widget. Y means it is being filled vertically. Left means the widget is packed against the left side. Then we also have the frame properties at the end. Here we have the game and what it looks like and how it is played.
Okay, the dealer class. For the dealer class, we created several different functions to help show the dealer score, which will help the dealer decide whether the dealer needs to hit or not. In the first function, the dealer score is retrieved and is set equal to the variable dealer_score. The second function returns a value which is displayed onto the screen for us to see. Similar to the second function, the third function takes that number displayed and changes it into a value which will be used to pass through the last function. Lastly, the last function has one parameter from the function above that is passed through the function and checked against the number 17. If the value passed through the function is greater than 17, it returns false, meaning the dealer will not hit. However, if the value passed through the function is less than or equal to 17, it returns true, meaning the dealer will hit again.
The purpose of the deal class is to kind of simulate situations you would see in an actual live game of BlackJack. We're able to do this by passing all of the information from MAME into this class. Like Taylor mentioned before, tkinter is what we use for the graphics. It's a GUI, and we were able to do that for the animations that you see like you would actually see at a casino table. So the use of self that you see in that image on the right, this allows us to access the attributes and methods of the class. It binds the attributes with the given arguments. The game properties are every event you could think of, we could think of when it comes to playing the game BlackJack, such as holding the scores for the players and the dealer. This stores all of that so we can compare the values later. It displays the results, such as a busted message if either the player or the dealer goes over the number 21, and then also it displays the results after the game is concluded. The entirety of this class essentially just keeps track of the scores while providing the options for the players as you see displayed. Next is the card class, and the purpose of this is it pulls the cards from the folder the images are being held in, and it shuffles them and gives them their proper names and values. We found out we were able to hide the second card as if the deck was facing down like a normal dealer would have the deck on a normal dealing table. We used random shuffle as the method to randomize the cards like a dealer would shuffle through the deck. And we used the actual photos pulled from the folder I mentioned earlier, and we had to actually resize these because the images were way too big to fit on the screen. And lastly, main. This essentially acts as the point of execution for the entire program. It's like the glue for everything. All the information in main is passed through the different classes, so that's why there's no really display messages or returns. It just kind of executes everything. It also sets the location of the cards on the table, so Taylor was in charge of graphics, so this allowed all of the locations and the buttons to look nice and allowed the cards to be placed in a way where the dealer would sit across from you like it would at an actual table. It also is in charge of displaying the scoreboard and updates those numbers after the player hits specific buttons, and the program does it itself for the dealer. And we were able to initialize the card instances, so this way we have a new deck every time deal is pressed. So it's like all the players give the dealer back all of the cards and reshuffles the entire deck for a new game.
We were going to implement machine learning into the game. However, we couldn't really figure out how exactly to configure it to our liking. We were initially trying to figure out a way for the AI to use probability and machine learning to make better decisions when deciding to hit or not. For improvements, we would definitely want to make it more realistic because in casinos, you are usually allowed to bet in the game. So adding a betting option and keeping track of your money throughout the game would make it a lot more realistic. Another way we wanted it to make it more realistic was to incorporate a way to play with multiple users, like the way they do in casinos, but having it at a max of 5 total players at the table playing against the dealer. We had a couple of different challenges, but the toughest one was definitely working remotely. Working remotely had problems within itself. Finding the best platform for us to meet was tough since, as you guys can see, not everyone had a computer with a camera. Wi-Fi also let us down at times. Scheduling was also tough because of the time difference between our group members. When brainstorming and continuing to work on the project, we had many different ideas about how we wanted the game to look and perform. Deciding and implementing each of our different ideas into one to come up with a game that we all agreed upon was a challenge as well. Along with having different ideas, each of us also had different coding styles. We also had different parts we were assigned, so variables easily could have been mixed up from person to person. So finding a way to implement each of our codes and coding styles within the project was also a challenge.